Hi Southwoods Math students, this is Mrs. Lindsay, coming to you today to talk about transformations of parabolas and their vertex. This is the first of two videos about transformations of parabolas. After this video, you will be able to complete slides 10 and 11. Tomorrow's video will teach you about slides 12 and 13. Please submit your slides by Friday, April 3rd. Just download them, type them, and submit them online, or you can print them and take a picture to submit. Let's get started. Here we have the parent function of the quadratic equation, f of x equals x squared. Note that there is not a constant rate of change here. The vertex is still at 0, 0. It is still concave up because the lead coefficient is positive, if you notice. That means it's concave up, but the rate of change continues to change. In other words, if we move over 1, we move up 1. If we move over another 1, we move up 3. When we move over another 1, we move up 5, and so on. If we had room on the graph, we could move over another 1 and up 7. So there is a pattern to the change. It grows at a pattern of 1, 3, 5, 7, etc. However, it's not a constant rate of change. The rate of change continues to change or grow. So let's take that parent function, f of x equals x squared, and let's talk about what would happen if we added 2 to the inside of the parentheses and subtracted 3 to the outside. Now notice that this is transformation notation. It has no square. This could be used for any function, including a square root function, an absolute value function, which we are going to get into later next week. We're going to talk about it as it applies to the parabola or the quadratic function now. But notice how these are just the instructions or just the directions. What do we do? Well, when we add to the inside, we shift the opposite and the horizontal. So when we add it to the inside with the x, it shifts in the opposite direction. We like to say inside lies, and it shifts horizontally. When we add or subtract to the outside, it shifts as the same sign and vertical. So the shift in this case was left 2 and down 3. So that would make the new vertex at -2, -3. So we went to the left 2 because inside lies, that's what the plus 2 came in, and down 3 because outside tells the truth. Now, what would the equation of that be? Now, when we talk about the equation, we have to allow for the fact that it's a quadratic equation, a parabola. So in this case, we're going to say that g of x equals x plus 2, to show that it shifts to the left 2, squared, that gives us the quadratic equation or the parabola, and down 3 or -3. So the equation has the squared in it to show that it's a parabola or a quadratic equation. It also gives the directions of the shift, left 2 and down 3. Now, let's talk about, on the next slide, what would happen if we decided to take the parent function, shift it, so now we have g of x equals x plus 2 squared minus 3, and then make it negative. Well, as we know, some of us remember, when we have a negative lead coefficient, that parabola is going to flip upside down. It's going to now be concave down. So this parabola is now going to look like a concave down parabola. But that's not all. If we made the entire function g of x negative, that means that that negative would have to get distributed to the two terms here. The first term being x plus 2 squared. Remember, never break into the bubble. That's all one thing. And minus 3. So both those signs would have to change. We would have to distribute the -1. So our new function, h of x, would be negative x plus 2 squared, and instead of -3, it would actually be +3. So how did that happen? Originally, our vertex was at -2, -3. But if you look at your parabola in the mirror, the parabola flips upside down. The vertex actually also flips over the x-axis. So you not only, when you reflect over the x-axis, you not only have to change the concavity of the parabola, but you have to actually change the vertex to reflect over the x-axis. What does that mean for the vertex? Well, our new vertex is now -2, 3, where our old vertex was -2, -3. Remember, the y coordinate is now opposite. So instead of -2, 3, it's now -2, -3. So now I'd like to talk about what would happen if we just made the x negative. In other words, I'm not making the entire function negative. I'm not reflecting over the x-axis, but I'm just making the x negative. What would happen to this graph? Well, let's see if we could make the equation first. So I'm going to go a little bit out of order here and say, what would happen if I took my original equation, f of x, and made it g of x, where only the x was negative. So it would be -x minus 3 squared. Well, what happened was just the x coordinate became negative. It actually reflected over the y-axis. So what would happen was, when the x coordinate became negative, was we had a reflection over the y-axis. It looks almost like a shift, but because if you look at the equation, we made x negative, it was just a reflection. It's like looking in the mirror of the y-axis. So when we make just the x negative, we reflect over the y-axis. Okay, that's the end of this video. You are now able to do slides 10 and 11 on your assignment. If you want to look at the next video tomorrow, you'll be able to complete the entire assignment. So good luck for today. See you tomorrow with the next installment of Transformations of Parabolas. Good luck.